So, what you studied in the last class is the addressing, IP addressing, that is usually basically used in the TCP/IP protocol suite, and in that what you studied is the different classifications of the IP addresses, and there are some special IP addresses and why the special IP addresses are used. That means what we understood is IP addressing is a scheme or that is to justify or to identify a system in the network. That is why we need an IP address. So, next to the IP addressing we will study something which is called the subnetting. What is subnetting and why you need subnetting? Let us say you have a huge network, a class B network let us say. You know the class B addressing that starts with the number 128 to 192, right. So, any number, any IP address that ranges in between belongs to the class B address, and in the class B address you have 16 bit of net ID and another 16 bit of host ID. So, x dot y, if they are the they identify the net ID, let us say a dot b identify the host ID. So, now in this network, that means if I say x dot y is a network having some host ID, and this host ID can contain, I mean this address or this scheme can contain how many hosts in a network? 2 to the power 16, which is quite large, right. So, if any IP address that comes with 144 let us say .14.2.19, let us say datagram comes to a network, and when it comes to the network it reaches to the router R1. So, when the datagram comes to R1, this R1 knows that I am connected to a subnet whose address is 144.14.0.0. Now, you understand why I put this 0.0, meaning this is the, if I put .0 in the host ID means this is network address. So, when the router gets the packet of this one, it understands that the network to which I am connected is the 144.14 network. So, definitely this host is in my network. So, what it does? It identifies the host with the IP address of 144.14.2.19 and delivers a packet to this, finding all its MAC address, corresponding IP address, all those things that we will see later. So, what the router job was to get the packet and to deliver the packet to the corresponding host. Now, to find this host, what the router had to do? It has to search all the network, all throughout the network having 2 to the power 16 numbers of, approximately 2 to the power 16 numbers of host. Definitely this is time consuming and which we cannot afford to that much of delay to find a host and deliver the packet. So, what is the solution for this? If you divide or if you fragment this whole bigger network into smaller networks, and only this subnetting or this division of the network is visible to the router, but not to the world outside the router. We can do that. That means dividing the network into smaller network, the bigger network into smaller network is called the subnetting. And this subnetting is known to the router who is connected to this, but beyond this, when a packet comes, it does not know where exactly is the subnetwork or network. So, what we can do now, the same router let us say connected to a network, a set of network you can say, or a subnetwork. So, this is one subnetwork, that is 144.14.2.0 let us say, then another subnetwork similarly some address with let us say 100.0 and another subnetwork similarly let us say 200.0. Possible? So, now these are again the network addresses and the host connected to this network will have the number something 144.14.2.1 starting from this till 144.114.2.255. So, all the hosts are now they belong to this subnet, and similarly other hosts will be connected here, and this is how the subnet is configured out of the bigger network whose address is the previous one 144.14.0.0. So, when the datagram comes here with the IP 144.14.2.19, now the router checks whether this belongs to any of the subnet or not, and the subnetwork is let us say this one 2.0. So, now identifying this 19 number host out of this subnet is definitely easier than finding the same host in the bigger network and less time consuming. So, now it identifies this subnet and delivers the packet to host having the address 19, correct. This is what is the objective of finding the or dividing the bigger network into smaller networks or called the subnetworks. Now, how the router knows this, that this address will be mapped to a subnetwork whose address is 144.14.2.0, how this is done? Or the earlier network, when it comes to the router, how the router knows that this belongs to a network whose address is 144.14.0.0. So, how from this whole IP this address is extracted, or from the whole of this IP how this address is extracted. Once that is extracted, then the router decides whether it is connected to that network or not, because router does not know where the host is. The router is only connected to the gateway node of any of the subnet, so he knows only the network address. That means getting the network address out of the IP address is a process called masking. So, masking is the process that extracts the network address from the corresponding IP address of a datagram, either the network address or the subnetwork address. If it is subnetted, then it will find the subnetwork address. If it is not subnetwork, then it will find the network address. So, that is what is the job of your masking. So, if you see the whole process, any IP that comes into a mask, the IP comes to the mask and this gives either the network address or the subnet ID, subnetwork address. So, what this masking is? This masking is nothing but a bitwise operation of the IP address and the corresponding masking address, or you can say the subnet address, subnet mask. So, how this masking is calculated or decided? If you get a mask like this, let us say your 144.14 whatever was there, let us say 2.19 was there, then the mask address is, if it is not subnetted, the masking is let us say 255.255.0.0. That means, if it is all ones, it says it is the net ID. If it is all zeros, it says this is the host ID. That means it is a two-layer hierarchical configuration, right. So, when this operation will be operated over this number, you will see that the outcome will be 144.14.0.0. This indicates your network address. This gives your network address. Let us say you have a subnet. That means you have a net ID as a bigger picture. Then after that you have a subnet ID, then you have the host ID. So, it is a 3-layer hierarchical structure. So, initially you will get the net ID, which network it belongs to. Within that network you have to find out which is the subnet ID, and then you have to find it which is the host ID. That is how your 3-layer searching of the host takes place in case of your subnetting. Now, in this subnet ID, how the mask is calculated? Again the same feature, if all ones, it gives the subnet ID, if all zeros, it gives the host ID. This is for the subnet mask. This is how your whole of the IP address is now fragmented into different sections to identify which network, which subnetwork it belongs to. Then the packet is delivered to a particular host which maps to the corresponding IP address with its physical address or the MAC address. Let us take an example, we will see how it happens. Let us say we will take a class A organization. Class A organization, what is the structure? First 1 byte is the net ID, then the rest of the bytes are the host ID, right? If this is host ID, this is net ID. So, the question is, if any organization having the class A kind of IP addressing wants to make a subnet of 1000 numbers, the organization wants 1000 subnets to be framed or to be formed in the network, in the organization. How it does? How it finds the mask, how it does the configuration, and how it finds what will be the valid IP address that can be given to the any of the host. You know what is a valid IP address and which is a special IP address, you have seen last time, right? In the last class, the special IP addresses cannot be allotted to any host because they are for special reserved for the special purposes. So, how you find a set of valid IP addresses from the range or from the domain and you allot the IP addresses to any host in the organization, how it is done. So, now total number of subnets required is 1000, correct? Along with that, let us also assume 2 more addresses, one will be all ones, that is your broadcast, and another is your all zeros, that is the network address. That means 2 IP addresses required, one will be for all zeros and another for all ones. So, total number of subnets will be 1002. We will reserve 1002 number, we will plan for 1002 number of hosts now. Now, with this number, so how many bits will be required now to identify or to form 1002 number of subnets? How many bits will be required? You tell me the higher number, the maximum number. 10. That means, if I say right. So, maximum we can spare, we have to spare 10 bits to form 1002 number of subnets. So, what is your subnet configuration? It is all this is for your net ID in class A and rest are all your zeros in a normal process or without having any subnet of the class A configuration. But when you are planning for the subnet, you know that for subnet address or subnet ID, you have to make all ones. So, how many ones we will make now? 10 bits of ones. Is that 10 now? That means from the host ID section, I am extracting that many number of bits to make them all ones, so that they will be identified as the subnets. So, now 8 and 2, rest will be as it is 0. They are all the host ID. Now, how many will be now subnet ID? This is my subnet ID. This is equal to, if I say 255.255 dot how much? This is of course 0. This is agree? 192? 192. That means this is my mask now. This is the mask which will be operated over any IP to find out the subnet address. Correct? Now, as a whole we have one network within which we have got total 2 to the power maximum 2 to the power 10 number of subnets, let us say 1024, out of which only we will frame for 1002 because we need that many only. Rest of the digits we are not going to configure, right? And rest all will be your 2 to the power how many? 8 plus 6, 14 number of hosts in every subnet. So, that means your configuration will be something like this. If these are the subnets, then the subnets will be starting from, let us say 0 to 1001, this many number of subnets, and in each subnet you will have 0 to 2 to the power 14 minus 1 number of hosts. Till this it makes sense, clear to everyone? This is how your configuration is done or your subnet mask is decided for any network having a specific classification. So, that means you are going to frame 1002 number of subnets and each subnet will have 2 to the power 14 number of hosts inside it. Now, let us find out of these subnets and out of these host addresses, which will be the what will be the special IP addresses and what will be the valid IP addresses for any host. Now, out of this, as a network designer you have been given the number, you frame 1002 subnets and give me the list of valid IP addresses. So, what you do now? Your mask is, as we saw, mask is 255.255.192.0. This is your mask. And in this what you see now, out of this 192, you have, sorry, so if I make all zeros any point, if I make all these zeros and rest of the things 1, that will be your, agree? When I am saying net ID means it is subnet ID actually, right? And if I say all ones along with this one also, that means this is again broadcast, agree? That means for every subnet ID I will have again 2 special addresses with all host ID is 0, all host ID is 1, and rest of the things will be as it is. So, now you start configuring this, because this is class A. Let us say x dot 0 dot 0 dot 0. This is address. The next one will be x dot 0 dot 0 dot 1. Just go on writing this, x dot 0 dot 0 dot sorry 63.254, and the next one will be x.0.63.255. How do we find this? Starts with the number very common 0, it goes on continuing till a point. That means when this is your subnet, what is your subnet ID? Forget this net part. What is your subnet ID? 10. This is your subnet, right? Make it all 0. This is your subnet section, right? So make it all 0. So till that point, that means how much you will get? This is this will be something x dot 0 dot, if these two are 0 and rest will be 1, what will happen? 63? Yes or no? Rest 6 are 1, 1, 2, 3, 4, 5, 6. What is this? 63? Then again rest all 1. How much? 255? So what is the last number then? Let me explain it here. You see, you starts with x point 0.0.0, go on increasing, then next number becomes x dot 0 dot 0 dot 1. Similarly, then it goes on till the which one comes first? The last one, 255, right? Then the next number, whatever is earlier 0 now, finally it comes to all ones. So when it comes to all ones, what is the number? 63, and by that time what is the subnet ID? They are still all zeros, right? So that is still all zeros, and x is any number. X is any number that belongs to the network. So my last number is x dot 63 dot, sorry, x dot 0 dot 63 dot 255. In this whole series you will find that, your subnet ID is 0. So for the whole series your subnet ID is 0. That means this is again a special address. Can you allot this address to any host? No. You take the first one even. You cannot assign, forget the subnet ID, the host ID all zeros. So you cannot allot this one. Even the last one, the host ID all ones. So you cannot again assign to any of them. That means the first line whatever you take, you see that all the host, all the addresses are special addresses. None of them can be allotted to a host. Coming to the next one, now your this one will be 1, I mean the earlier one. Next one will be x dot 0 dot 64 dot 0. Agree? Because your this number will be now, where is that? Yeah, this number will be now 1 and rest of the things will be again 0. So what happens, what is the number you are getting? X dot 0 dot 64 dot 0. But still, now this is a valid subnet ID. But can it be a valid IP address? No, because host ID again all zeros, right? Because all this 8 plus 6, all these 14 digits are again 0. That means this is again becomes a special address, x dot 0 dot 64 dot 0. The next address is x dot 0 dot 64 dot 1. Now you tell me, is this a valid IP address or not? It can be. The reason behind is your x is there, forget this 0, but 64 there is a 1, that means subnet ID is not all zeros, not all ones. And your host ID at least 1 is there. So not all ones, not all zeros. That means your valid IP address starts at this point, x dot 0 dot 64 dot 0, and then x.0.64.1. Here comes your valid IP address, and it continues till x.0.64.2, x.0.64.3 till x.0.127.255. Check it. So, when it comes to 127.255, again you will find that these all host IDs are 1. So, again this column, the last column is not a valid again, rest of the things still this is okay. So, this is valid, this is valid, this is valid. Right. So, what you are considering, what is the objective of making this table is, if you configure this, you will find that when all the host IDs become 0, they come into one column. When all the host IDs become 1, they come into another column. When all the subnet ID is 0, they come into this row, and at the end also when you will see, you will find that when all the subnet IDs are 1, subnet IDs all ones, they come into the last one. And in between whatever you will have, they are all the valid IPs. So, out of the total number of range of addresses that you generated from the class A kind of IP, with all this configuration 32 bits, you will find only this many number of valid IP addresses, and rest are not valid. Maybe for they are either the subnet address, or they are the network address, or the host ID is broadcast address, or the any other specific address. So, how many subnets you are getting? If you will find, these are all the subnetwork addresses. These are all the subnetwork address, and in every subnet you will find one all zeros, that is this a network address, and all ones which is a broadcast address, not given to any of the host. In between any number you find, that becomes your valid IP address. This is how the IP configuration is made in any organization. First they decide what classification we are going to have, class A, class B or class C. Once that is decided, once that class is decided, then you decide how many subnets are required. Then you decide what is the mask. Then you configure the network, finding the valid IP addresses and the special IP addresses. They are not invalid, but they are special. Right? Now, work out a small example, it will be easier for you to understand. Let us say class C organization. What is our institute IP address scheme? 192 means it belongs to which class? Class C. Okay. So, class C means what? Class C means x.y.z is your network address, and only the rest let us say 00000000. This is your host ID, right. So, this is your net ID. Just this is an example, I am saying we will go for the, we will work out the other example later. Just tell me now one question I have. So, with this host ID, how many every network, how many hosts it can have? 2 to the power is equal to how many? 256. 256 minus 2, why minus this 2? 20 and this, okay, fine. Now, what is your subnet mask used? 255, 255, 250, 254. Who says 254 or any other number? 2540. Next time when you go to the lab, you check what is this number. 252. I accept this 252. Okay. But what should be our mask actually? Dot? Right? How come we get this 252? We have a class C because 192 starts with, quite obvious, and by rule it's 3 byte is your for net ID and your mask should be 255, 255, 255, but we have a mask of 252. How is it possible? This is your assignment homework, do it and tell me in the next class. Okay. So, other than this, let us work out a problem now. Class C, just do, let us have an organization having class C network and it wants 5 subnets. Very easy. A class C organization wants to have 5 subnets. Find the mask and find the list of valid IP addresses. A class C organization, any problem? Ask me. Class C organization wants to have 5 number of subnets, find the mask and the valid IP addresses. Do it, 5 minutes.